this one too. All right, so the first sentence say a unit vector is a vector of magnitude 1 unit. Okay, that's just a definition of a unit vector. Okay, and then I just copy a diagram from problem 66, and it's give you 25, 24, and 7 for a side length. They ask you to draw a unit vector with the same initial point and the same direction as a vector of magnitude 25. So if I draw the same one, and the magnitude is only 1, so my initial point is right here. Okay, initial point, and this is the terminal point, but I will draw starting from the same initial point. However, the restriction is my magnitude has to be 1. So that means I have this. This is 1. Okay. So then from there, I can drop down and make another right triangle. So then now I have to find a component of this vector. If I find a component, that means I will need to find the values for x and y. So if some of you can see it right away, but some of you have to redraw them as 2 separate triangles to see what concept we need to use to find x and y. So I already have the big one. I can redraw the second one right here. This is 1, this is x, this is y. Anyone can come up with an idea how we solve for x or how we solve for y based on your prior knowledge that we already learned in the past. Okay, try to find in your brain, is there anything we can use to apply to solve for x and y? Law of cosine. In order to use law of cosine, we need to know the angle, but we don't have any angle in this case. Pythagorean theorem. For Pythagorean theorem, you only can find the third side length if you already know 2 of them. But in this case, we only know 1 of them and the other 2 are unknown. But you try and I appreciate it, Trung Anh. Set the size equal. I think you're on the right track, Aiden. Okay. All right, so yeah, that's actually the right idea, and hopefully you guys still remember we learned similar triangle in integrated math 1, right? So since we have these 2 triangles have angle, this is the angle case because they both share the red angle right here, and they both 90 degrees right here. So that's the angle case. So they are similar triangles. Yeah, I know, 3 years, right? Not too long, but not too short to forget it, right? Anyway, yeah. So then that allows us to set up proportions between the side lengths, just like Aiden brought up earlier. So then we can have 25 over 1 equals 7 over x. And you solve for x from there. And then another set you can have is 25 over 1 equals y. Sorry, not y, but 24 over y. Go ahead, calculate. Let me know what is x and what is y. So I'm waiting here. X equals y equals. Hopefully you guys don't forget cross multiply method. Yes, okay. So x is 7 over 25. I try to keep it as fraction because we will talk to the next part why why this is the unit vector. All right, so yeah, we have 7 up over 25 and y equals to 24 over 25, and the component of this vector right here, the unit vector, so component of the unit vector in this case is 7, 25, and 24, 25. And now, if you take those two, you add them up, you try to find the magnitude, it will equal to 1. So we double check it. So the magnitude is 7 over 25 square plus 24 over 25 square, and take the square root, equals, and this is the magnitude of unit vector. So let's call it vector u. So then the magnitude of this, after you calculate, you should have 1. So conclusion is, whatever vector that the magnitude equals to 1, we call that one is unit vector. Okay. Hopefully this problem help you understand a little bit more about unit vector.